Welcome to Math 1300, Nunez Community College. This section today is going to be section 1.4. 1.4 is going to be quadratic equations. An equation has an equal sign, but an equation is quadratic in nature when it has an x that is squared. When it has an x that is squared. In order to solve a quadratic equation, we're going to break it down into individual x's, or x's to the first power, and we're going to solve. In order to do this, we're going to factor it. Factor means to divide, so we're going to factor it. So the first question that they're going to have is going to look similar to this. Suppose I have x squared plus 9x equals 0. X squared plus 9x equals 0. Factor means to divide out. We are going to divide something out that's in common with both of them. This first one, the only thing in common with both is an x. So we'll factor an x out. What I'm going to write in parentheses afterwards is what is left if I factor an x out of both terms. If I factor an x out of the first one, I'm left with an x. If I factor an x out of the second one, I'm left with a 9. We now have split it up into x's to the first power. But this times this binomial equals 0. The two things are multiplied together. In order for things that are multiplied together to give me 0, means that one of the two has to be 0. Either this one has to be 0, or the other one has to be 0. Either way, 0 times a number
can you please
gives
call
me
the front
0.
office? Miss Hoover, can you please call the front office?
So in order to solve, we need x equals a number. The one on the left is here already, x equals 0. So therefore, this is an answer. The other one, we need x by itself, so I'm bringing 9 to the other side. So I subtract 9 from both sides, and x equals -9. 0 and -9 are the solutions to this problem. If you would like to go back in and check, you can. 0 squared is 0, plus 9 times 0 is 0, 0 equals 0. -9 squared is 81, plus 9 times -9 is -81. 81 minus 81 gives me 0. You may check if you want, but you are not required to. From there, we move on to quadratic equations. That's a little bit bigger. We move on to what's called trinomials. Trinomials because there are 3 terms instead of 2. Suppose I have x squared plus 2x minus 24 equals 0. Trinomials usually factor into 2 binomials. And the way I like to mess with it is we've already multiplied the binomials together in order to get the trinomial. Now we're going to divide them out. So it's like when we did FOIL to multiply them together, we're going to undo FOIL in order to factor them. Undo FOIL in order to factor them. So this first term would have been the 2 first terms multiplied together. So what times what gives me x squared? X times x gives me x squared. Then we have what? The last. Let's go to the last term first. The last term is what? The 2 last multiplied together. So I need 2 factors of 24. In this case, -24. Well, we have what? 1 and 24. We have 2 and 12. We have 3 and 8. We have 4 and 6. Well, one of these combinations has to multiply to give me 24, but through the insides and outsides needs to add to give me positive 2x. The only ones that have a difference of only 2 is 4 and 6. So one of them has to be a 6, one of them has to be a 4. Since this is a -24, one's got to be positive and one's got to be negative. But when we look at the insides and the outsides, they have to combine to give me a positive 2. So the 6 has to be positive and the 4 has to be negative. This would give me a 6x on the insides. And by the way, the insides and the outsides is O and I for FOIL, insides and outsides. And the outside would give me a negative 4x. 6x and negative 4x gives me 2x. That's what I'm looking for in the middle. So this is the correct way to factor it. So far we have factored. The trinomial factors down to two binomials. We've accomplished taking the x squared and making them both x's. Now, just like the last problem, if they both multiply to give me 0, either this one is 0 or that one is 0. So if the first one is 0, I got x plus 6 equals 0. The second one is 0, x minus 4 equals 0. When I solve, x equals negative 6. And when I solve, x equals positive 4. So that is the two answers that I get, negative 6 or positive 4. Negative 6 or positive 4. Now, a lot of times people are factoring a trinomial, and it's all fine and dandy when it's like this. But when we put a lead coefficient in, a lot of students give up or don't know how to handle it. Suppose I have 4x squared minus 4x minus 3 equals 0. So this is what I mean by a lead coefficient. The lead thing has a number in front of it. So x squared has a number in front of it. Well, we know that it factors to the two binomials. And we know that what? The first two terms, first times first, has to multiply to give me the first term. And the last two terms, last times last, has to multiply to give me the last term. But how do we put them in? The first one is 4x squared. I'm going to try 2x and 2x. Because 2x times 2x gives me 4x squared. Or 4x and 1x gives me, I'm going to try the two that are closer together. Most of the time, the two factors that are closer together are used more than the factors that are farther apart. And 3, in order to give me a 3, well, that's a 3 and a 1. Again, this used to be called trial and error, and I guess it still is, but we're making sure by putting our numbers in and see what we're going to get. So I know that it's got to be a negative 3, so therefore either the negative is going to go here or the negative is going to go here. And I know that the middle term has to add up to negative 4x. By looking at it, I'm saying again, the outsides are going to give me what? 6x. And the insides are going to give me what? 2x. It does give me a 4x. But which one has to be negative? The 6x has to be negative, so therefore the negative goes with the 3, and the positive goes with the 1. Again, that gives me positive 2x on the insides. That gives me negative 6x on the outside for a difference of 4x. With these, where you have a lead coefficient, it's trial and error. You got to keep playing with it and playing with it. And the more that you see, the more of these that you do, the more you're going to see exactly what you need to put in here to make to satisfy what it has. So again, 2x plus 1 equals 0, or 2x minus 3 equals 0. For this one, if I bring the 1 across, I got 2x equals negative 1, x equals negative 1/2. That's one of my solutions. On the other one, I got what? 2x equals 3, x equals 3/2. That is my other solution. Again, with lead coefficients, don't be scared of it. Just try to see what combinations you can have to make the inside and the outside add up to be the middle. This is known as factoring. And this is what, again, a lot of these you can do, and it's fairly fast. But that's not the only way we can achieve answers. Depending on how the quadratic equation looks, might make us want to use other methods. Another method that they have is going to be the square root method. The square root method. And that method says that if we have x squared equals c, meaning x squared equals a number, in order to undo the square, so first of all, x is isolated. X by itself is equal to c. In order to undo a square, we'll take the square root of that. The square root of x squared equals x. They undo each other. But if I take the square root of one side, I have to take the square root of the other side. Now, the square root method is special because it's saying that this number times itself gives me that squared. The problem here lies is that the negative of this number times the negative of this number also gives me that number. So when taking the square root, we must always write both plus and minus for the c. So if x squared equals c, that means x equals the square root of c, and x equals the negative of the square root of c. So we must always remember that when taking the square root method, in order to do it, we square root the number that's here, both plus and minus. Both plus and minus. It'll make a little bit more sense when I do one. Suppose I have that x squared minus 8 equals 0. X squared minus 8 equals 0. Well, in order to do the square root method, we have to isolate what's squared. So that means we isolate what's squared, get everything else away from it. So that's going to be x squared equals 8. Bring the 8 to the other side. Now when we take the square root method, we got the square root, both plus and minus. X equals both plus and minus square root of 8. Plus and minus square root of 8. Now the square root is not a perfect square. It's not a perfect square. So we go back and take our prime factors. 8 could be a 2 and a 4, and 4 can be a 2 and a 2. And since it's the square root, we need 2 of them, 2 of the same number, which I have 2 2's, to take 1 out. So that would be 2, and then we have 1 lonely one that's left here, so that's the square root of 2. So the square root of 8 breaks down to 2 times the square root of 2. So it would be x equals both plus and minus 2 times the square root of 2. That would be my answers. That would be my answers. If I had one that actually factored, not factored, but was a perfect square, you could see x squared equals 4. I'm doing that because 4 is a perfect square. Yes, the perfect square root. So if I took the square root of both sides, you would see that x equals the square root of 4, which is 2, right? Because 2 squared gives me 4, right? However, negative 2 squared also gives me 4. So that's why it's both the plus and the minus. Because 2 squared, 2 times 2 gives me 4, and negative 2 squared, negative 2 times negative 2 also gives me 4. So therefore, that's why we do the plus and minus. I wanted to do it with a perfect, a perfect square root, because sometimes when you have things like this, it can be a little confusing. Okay? Another one that we have might look like this. As long as what is on one side is all squared, we can do that. So suppose I have x minus 4 plus 4, squared equals negative 27. Since this whole thing is squared, this is considered isolated on the left. I can take the square root of this whole thing and take the whole thing out of the square root. So therefore, the square root of x plus 4 squared is just x plus 4. And that is equal to plus and minus the square root of negative 27. Well, remember, the square root of negative 27 could be what? The square root of negative 1 times the square root of 27, but 27 could break down to what? 3 and 9, which is what? 3 and 3. I have 2 3's, so I can take the 3 out. This is the lonely 3, so it stays as square root of 3. So this would be negative 1 times 3 square root of 3, which is going to be what? 3i square root of 3. So 3i square root of 3 is what I'll put in this slot. And then what? Bring the 4 to the other side. So x equals negative 4 plus or minus 3i square root of 3. That is the square root method. That is the square root method for solving quadratic equations. Okay? There's another method that they're going to ask you to solve it by this method. Not a lot of people like this method, but I'm going to show you anyway. You might fall in love with it and want to use it all the time. It's called completing the square. It's called completing the square. So if I have something like x squared plus 4x minus 6 equals 0, I look at it and I said, all right, well, let me just try to factor it. But I can't get factors of 6 that add up to 4. 6 and 1 don't add up to 4. And what? 3 and 2 don't add up to 4. So the completing the square method would take the 6, since we don't want it, and move it to the other side. So I move the 6 to the other side, and I'll leave a gap, and I'll put it over here. The reason I'm leaving a gap is because the 6 didn't work for factoring. I want to put in the number that does work. So if I find the number that works, I'm going to put it in right here. And I'll also put it on the other side, because if I do it to one side and I do it to the other side, it's fine. It's perfectly legal. How do I find the number that goes in here? There's a formula called b over 2 squared. Now remember, this is a, b, c, so therefore this is the b. So b over 2 squared. So 4 is the b. 4 over 2 squared. 4 divided by 2 is 2 squared, which is 4. So I want to put a 4 into this spot. So it's going to be a plus 4 and a plus 4. By the way, whatever you put in here is always going to be a plus. Always going to be a plus. Now what do we have? Well, this is now suddenly a trinomial that factors quite easily, but it factors being the same thing. X and x to give me x squared, 2 and 2 to give me 4, plus and plus, and what does it have? 2x, 2x to give me 4x. So it factors in the two things that are the same. We can say, since it's the same, it's x plus 2 squared. Again, completing the square. We're completing the perfect square. And then that's equal to 6 plus 4, which is 10. Now look at what we have here. This looks exactly like a problem we can do the square root method with. This is isolated by itself, equal to everything else. So we'll take the square root, both plus and minus. X plus 2 equals plus and minus square root of 10. Now the square root of 10 does not break down because the only factors are 2 and 5. So we don't have 2 of any particular thing. So we bring the 2 to the other side, and x equals negative 2 plus or minus the square root of 10. This is completing the square. This is completing the square. Completing the square is not too bad as long as the b term is even. When the b term becomes odd, we then have an odd number over 2, which does not come down to something pretty. We then deal with fractions. And I know that a lot of people don't like dealing with fractions, so if you can avoid it, I guess I would try to avoid it. If not, and you like it, more power to you. And then comes the last one that we have in our arsenal for completing quadratic, or for solving quadratic equations. The last one is the one that always works. It's the one that if you can't see to factor it, if you can't see to do completing the square, if it's not available for you to do the square root method, there's something called the quadratic, since we're dealing with quadratics, formula. someone came up with a formula that is allowing us to solve for quadratics. And x is what we're looking for, x equals, so it's x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This is known as the quadratic formula. And remember, ax squared plus bx plus c equals 0. So that's where the a's, the b's, and the c's are coming in. That's where the a's, b's, and c's are coming in. So let's look at see what we can do with trying to solve one. Suppose I have 2x squared plus 8x minus 7 equals 0. Minus 7 equals 0. Well, in this particular one, I can't factor it. Even trying to do what I can do with the insides and outsides, I can't factor it. So I'm going to resort to the quadratic formula. In this case, we know that a is equal to 2. I know that b is equal to 8. And I know that c is equal to negative 7. So I'll plug it in. I have x equals negative 8 plus or minus the square root of 8 squared minus 4 times a, which is 2, times c, which is negative 7, all over 2a, which is 4. 2 times 2 is 4. Now it's just doing what I have to do inside the radical, so I can simplify it. Negative 8 plus or minus the square root of 64 plus, that's going to be what? 56 over 4. So x equals negative 8 plus or minus, this is going to be the square root of what? 120 over 4. So now we need to break down this square root of 120. So I'm going to come back over here. We're going to do 120. We'll do the factor tree. 2 and 60, 2 and 30, 3 and 10, 2 and 5. Well, we got what? A pair of 2's. I can take a 2 out. All this can't be taken out though. So it's 2 times the square root of all these things multiplied back together, which happens to be 30. So square root of 120 breaks down to 2 times the square root of 30. So that gives me, let me put it right here so that I'm not getting too low. I got x equals negative 8 plus or minus 2 square root of 30 all over 4. That would almost be good enough except for the fact that I know on the top I can factor out a 2 and I know on the bottom I can factor out a 2. So if I factor out a 2, I got what? Negative 4, if I factor a 2 out of here, plus or minus, factor a 2 out, so I'm left with square root of 30 over 2 times 2 to give me 4. Reason I did that is because now I have a 2 on the top and a 2 on the bottom to cancel. And that leaves me my final answer, which is negative 4 plus or minus the square root of 30 over 2. That concludes factoring. Now you can choose one of those methods and you'll be able to factor almost anything that's given. Alrighty, well, that concludes it. I'll see you at the next one.